Good morning, student. In this class, we are going to discuss about the intensity of a sound wave. Intensity of a sound wave. Okay. In the last lecture, we have discussed about various terms related with the wave, like the excess pressure, the displacement, the energy of the wave, its expression for kinetic energy or potential energy, etc. But intensity is the most practical thing to consider when we consider about the sound, because we usually ask people like how much intense the sound is. If the sound is very intensified, then it's very painful to your ear. Okay, so intensity is the most practical thing to consider in a wave, especially in the sound wave. Okay, so what is the definition of intensity? Intensity definition is if we represent intensity by I, then intensity represent energy of the wave over area into time. That means energy of the wave per unit area per unit time. This is the definition of intensity of a wave. Okay, we know energy, if SI unit will be equal to energy of the wave, always expressed in joule, because energy unit is joule, and the area is meter square, and time is equal to second. So joule meter square per second, this is known as the SI unit of sound intensity, and joule per second is equal to watt. Therefore we can write watt over meter square. Okay, watt into meter to the power minus 2. This is a typical SI unit for intensity of a sound. Okay, but in the above expression, in the previous expression, what we have calculated, the typical energy density, not the absolute energy, but the energy density of a wave. So we can express intensity with regard to energy density also. For example, if we write an expression like I is equal to E into C, where E is the energy density and C is the velocity of the wave, then if we do the unit analysis, then you can see energy density has the dimension unit of joule per meter cube. Energy density, so the energy per unit volume, so joule per meter cube into C is equal to meter per second. So basically it will give us joule meter square per second, so watt to the power meter to the power minus 2. Therefore I is equal to E into C. This is a good definition for intensity of a sound wave. We have already calculated the value of E, so you have to just plug in the value of E here, and you can get the expression for intensity. For example, we have already derived that the energy density of a wave, E is equal to, how much was it value? Half rho naught W eta m square. Okay, it was probably, sorry, W square into eta m square. It was the expression for energy density of a sound wave. Therefore the intensity of the sound wave will be simply half rho naught omega square eta m square into C. This is the expression for intensity of a sound wave. Okay, so do you have any idea what sort of sound intensity a human ear can hear? Okay, so its value is typically I is equal to 1 into 10 to the power minus 12 Weber per meter square. This is known as the quietest sound. I mean, the human ear can hear this intensity sound. This is 1 into 10, which 1 divided by 10 to the power 12. So it's a very small unit. Okay, so this is the quietest sound a human can hear. A human can hear. Okay, so you see the unit is so small that it's very difficult for us to imagine. Okay, so it's a very small unit for us to imagine. Therefore people have used a different form of unit which can you never heard the intensity of sound is expressed in watt per meter square, because this is a very small unit. And most of the time you have probably you have known you know that the intensity of sound is expressed in the form of decibel. Okay, decibel is the most commonly used unit for sound intensity. How the decibel is defined? For example, let me write this as level. The intensity level is defined as level is equal to 10 log logarithm with respect to 10 base and I divided by 1 into 10 to the power minus 12 decibel. Okay, this is typically used value for sound intensity. Sound intensity level, this level is actually intensity level. Okay, intensity level is defined as 10 log 10 I divided by 1 into 10 to the power minus 12 decibel. Okay, so this way the decibel sound is and decibel unit is defined. Here the unit of I is always in watt per meter square. Okay, so let's see the value of the quietest sound that human ear can hear. For example, this value is 1 into 10 to the power minus 12 Weber per meter square. So if we plug in this value, then the intensity level will become 10 log 10. This is 1 into 10 to the power minus 12, 1 into 10 to the power minus 12. These two things get cancelled out, then this value is equal to 0 decibel. Okay, so human ear can start hearing sound from 0 decibel. Okay, and I mean, for example, now if we consider a typical sound intensity about 1 into 10 to the power, say this is intensity I is equal to 1 watt per meter square. Okay, let's convert it into decibel and let's see how much this level of intensity will be. Level of intensity is equal to 10 log 10. Okay, 1 into 10 to the power minus 12. Okay, decibel. So this value will be equal to log minus log 1 into 10 to the power minus 12 decibel. So minus 12 will come out, minus 10 into minus 12 into 1 decibel. So this will be equal to 120 decibel. Okay, so 1 watt per meter square is a very powerful sound. If your intensity level becomes more than that, it will be very difficult for it. Sometimes it becomes painful for your for hearing. Okay, so 1 watt per meter square, if we convert into decibel, it will be 120 decibel. Okay, so this number, I mean, human can easily understand 1 decibel, 120 decibel. These numbers are very easy to understand. But if somebody says sound intensity is 1 into 10 to the power minus 6 watt per meter square or 10 to the power minus 12 watt per meter square, these numbers are really difficult to guess. Okay, so decibel is a unit to which our hearing capacity is most sensitive. Okay, that's why it is widely popular unit, and most of the intensity of a sound is expressed in decibel unit. Okay, let me plot a diagram of sound. From there you can understand what is the importance of decibel unit. For example, in the x-axis, say in the this point we put quiet and this point we put loud. Okay, and here this is a loud sound and this is a quiet sound. Okay, and here let me put the intensity of sound. So let me say intensity up to 1. Okay, so this is a 0.2, 0.4, 0.6, 0.8 and 1. Okay, and if we plot intensity as a function of loudness, for example, when intensity is say almost 0, then say very close to 0, then we say it's a very quiet sound, and as the intensity increases, let's say it as a loud sound. So if we plot this intensity versus quiet plot in an absolute unit, say this is in the unit of watt per meter square, as you can see, this plot will be something like that. Okay, so it's very difficult to see when the sound become loud and when the sound become quiet, because up to this part the value is quite the intensity value up to this level we can say it is quiet, and after that suddenly it increases exponentially. So if you if you have this kind of plot, then it will be very difficult for you to tell exactly what intensity level we should apply so that the sound does not become loud, because loud sound is very painful to the ear. But now if we convert this watt per meter square into decibel unit and again plot this plot it, then you will see a plot like this. This is a loud sound and this is a quiet sound. Okay, and this is in, now the unit will be in decibel. So if I plot, it will be like 40, 60, then 80. Just I am taking the logarithmic value, then 100, then 120. 120 correspond to 1 meter watt per meter square. So it will basically become a straight line. Okay, so this nonlinear function, it has converted into a linear function. Now you can say that 80 decibel is not so much loud. Okay, 100 decibel still not that loud. 100 decibel, it has reached the limit of the loudness. Okay, so the advantage of using decibel unit is that it is a linear scale of sound, say loudness. Okay, so loudness is a linear function of the decibel, but loudness is never been a linear function of this absolute unit, which is watt per meter square. That's why in most of the consequences you will find that the sound intensity is always expressed in the decibel unit. Okay, so 120 decibel is we can say it's a loud sound. Of course, human ear can hear sound having intensity more than 120 decibel, but it will become very painful to his ear. So it's the limit of the loudness. Okay, so this is what you need to know about sound intensity, and I will request you to please go through your textbook to find out what different level of loudness a human ear can hear. Okay, so basically you have to remember this expression when we will do some numerical example. Then you have to remember this expression: I is equal to half rho naught omega square eta m square into c. So intensity depend upon on the density of the medium, frequency of the sound, the velocity of the sound, and also amplitude, how much loudly you speak. Okay, that will depend on your amplitude. So these four quantities the sound intensity will depend on. Okay, thank you.